All right, welcome to section 1. In module 0, you had the chance to either learn a little bit about Python or, if you've already taken Python, to show me your final project out of your 1400 Python class. I also showed you a side-by-side comparison of 3 programming languages, Java, Python, and C++. Since 1400 teaches Introduction to Programming in both Java and now Python, I thought we'd do a little bit more comparison between those 3 languages here at the beginning of section 1. So how about let's look at the 3 of them compared. So C++, created in 1979, it was actually born out of the C language as an object-oriented language, and it is what is called a compiled language. Python, created in 1991, was actually born out of a language called ABC. I'd encourage you to go look that one up. It is also object-oriented, but it is an interpreted language, not a compiled language. And then we have Java itself, created in 1995. It is very similar to C and C++. I call it a sister language to C++. It is also object-oriented, but we're going to see that it's kind of a hybrid between a compiled and an interpreted language. So let's see what that means. So C++, a compiled language. Other languages like C, COBOL, and they process the whole entire program at once. It translates the program into machine code or binary code, and from there it creates what is called the executable. And as long as you have that executable, you can run the program to generate the output. You don't need the source code as long as you have the executable. You don't need to run the source code again. An interpreted language, such as Python, other languages like HTML and JavaScript are all interpreted languages. They process one instruction at a time. Instead of compiling or translating the entire program, it interprets one single line of code at a time. It executes the program by loading and translating the instructions on the fly, and it runs the source code every single time the program is executed. So the primary difference between an interpreter and a compiler, think for just a minute, if you are in a foreign language and you don't speak the language, so you have some kind of an app on your phone and you speak into the app and then you turn it to the native language speaker and it'll interpret that code for you, or the words that you're saying. A compiler, on the other hand, imagine for just a minute that you are at the United Nations and there is a foreign leader on the world stage, and in order to understand what your foreign leader is saying, he has prepared in advance the entire speech. He has given it to your interpreter. They sat down the night before and they changed everything into your language. And then they handed you that document that shows the entire speech in your language. That's the example of a compiler. It compiles the entire code in advance. The interpreter does it on the fly. And we're going to see that Java is a hybrid between a compiled and an interpreted language, because the source code is run through a compiler and generates what is called a bytecode or a Java bytecode. And this bytecode can run on any computer that has a Java virtual machine on it. It is run through the JVM to produce the output. So the JVM enables a computer to run a program written in any language that is compiled in Java bytecode. Compiled languages are platform dependent. They can only run on the same computer platform that it was created on. Interpreted languages, on the other hand, and compiled or hybrid compiled and interpreter languages are platform independent, which is one of the reasons why Java is so popular on the internet, with a variety of different computer platforms that are in use. All right, so let's look at the 3 programming languages side by side. We're going to evaluate a program that does the exact same thing. It's going to print to the screen, hello world. You already had watched a video of it doing this. So this is an example of Java. So Java has a public class. Our public class is called main, and then inside of that public class it has another function or another method that is called main, public static void main. And inside of that inner main function is a line of code that will print to the screen hello world. And if you'll notice, it uses system.out.print, and then inside of the parentheses is the string literal hello world. This is what it looks like in Python version 3. All we really need is a print statement, and inside of those parentheses is the string literal hello world. It takes one line of code. C++, on the other hand, is going to use a pound include. It's going to use namespace std. That's the standard namespace. It also has a main function, which is called main. And the line of code that is going to print to the screen is cout, which stands for console out. And then notice the two less than symbols, and then we have a string literal immediately after that. And then we have two more less than symbols followed by ENDL. That stands for end line or new line. Now the Python the print automatically generates a new line when it's done. In Java, if I had wanted to force a new line, instead of system.out.print, I would have put system.out.print line or print out n. Back to our C++, it ends with return 0. So it is returning a 0 value to the function that is called main. So there's a couple of things that I wanted to point out. For instance, Python version 3 is what is shown on the screen, has a lot of noticeable differences from Python version 2, most notably is the parentheses around the print statement. That's because in Python version 3, print is now a built-in function, and it is no longer just a statement. Between the three of them, both Java and C++ use dual backslash for single line comments. So I see an example of the end main and the end class, and here on the end main in my C++, they're dual or two forward slashes. Multi-line comments are the / asterisk to open and the asterisk / to close, both in Java and C++. Now in Python, a multi-line comment is 3 tick marks to open and 3 tick marks to close, and then the pound sign for a single line comment. Some of the additional differences is that Java and Python use import statements. Now neither one of these have imports, but C++ uses what is called include. So I see a pound include. It's the same thing as the Java and Python import statements. One of the biggest differences between these three languages is the semicolon. Java and C++ both use semicolons at the end of every executable line of code. Python does not use semicolons. Another difference is that Java and C++ use curly braces to indicate the body of a function. So in Java, we have our public class with the opening and closing brace to indicate the class. We have a main function with the opening and closing braces to indicate main. The same thing in C++. I have an opening and closing curly brace to indicate the parameters or the scope of main itself. But in Python, here's an example in Python of a function. Now Python doesn't have to have a main function, but it can be used to define the initial starting point in the program, especially if you had a Python program with multiple functions in it. And so if you'll notice in this main function here, instead of using curly braces to indicate the body of the function, it uses indenting. And then it uses if name is equal to main in order to call the function. All right, so that's the primary or some of the differences between the programs. Let's look at some of the differences in the data types. So if you'll notice, all of the three programming languages have whole numbers and floating points and booleans and strings. I want you to notice that Python has no formal double or char data type, because in Python, if it's a string with one character, or you can have a string with multiple characters, where in both Java and C++ you have a specific data type that holds a char, a single character. Python also has no formal double floating point data type, because Python, you can just, in a floating point, it can expand to any size that you need it to be. It would have to be an extraordinarily large number to overflow that float data type. So how about some of the basic operators? So once again, the Java and the C++, the math operators that you're using are pretty much the same. I want you to notice that Java and C++ have no exponent operator. Java actually uses a math function, and we're going to see how to do exponents in C++. Another difference is that Python can actually calculate integer division. Floating point division, if you have two floating point numbers, you get a floating point answer. If you have a int and a float division, it will automatically give you a floating point answer. But in Python, if you want to do either floating point division or mixed division and you just want an integer answer, you can do integer division. And Java and C++ also have the increment and the decrement operators as well. So let's see if there's any difference in the relational or the logic operators. Looks like all three languages use the exact same symbols for the comparison operators. The logic operators are a little bit different. Java and C++ are the same, but Python, instead of using symbols, uses the words and, or, and not. And so the next one would be escape characters. Is there a difference between the escape characters in the three different languages? Python has not only a horizontal tab, but a vertical tab as well. We can see that Java and Python also have the ability to backspace, do a carriage return, and a form feed, which is a new page, not just a new line. So these are some of the differences between the three languages. So how about if we actually start writing some C++ code?